name is Alejandro, and welcome back for day 42 of me doing the NeetCode 150 challenge. So today we're doing another medium stack problem, and without further ado, let's get straight into it. Okay, today we're doing a NeetCode medium, problem 150, evaluate reverse Polish notation. Okay, okay, seems like I will clear this right away. Seems like we have solved this problem before. July 26, 2024, which means that was probably one of the daily NeetCode challenge problems that I did. Okay, very sweet. Let's do this again then. You are given an array of strings tokens that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. Note that the valid operators are plus, minus, multiply, and divide. Each operand may be an integer or another expression. Okay, the division between any two integers always truncates down towards 0. Okay, there will not be any division by 0. Okay, the input represents a valid arithmetic expression in a reverse Polish notation. Okay, the answer and all the intermediate calculations are represented in a 32-bit integer. What is reverse Polish notation? Okay, jeez. Okay, this is a huge Wikipedia. I don't remember this. Let's look at an example. So here we have 2, 1 plus 3 multiply. So output is what? 9. Okay, so it's just take two numbers and do an operation on them. Then take that and whatever the next number is and do an operation. Okay. So here 4, 13, 5 and then divide. Oh, okay. So whenever there's an operation, you do the last two numbers. Okay. Which, yeah, is perfect for a stack. In a case like this, you add the last two together, and then you put it on the stack, and so when you get the 3, you do multiply. Okay. So this is rather simple, right? We're essentially going to do, we'll have a stack, and this makes sense, right? This is a NeetCode 150 problem, it is a stack problem, and so on, so, but this is just like what I'd intuitively think of. So essentially, it's like whenever there's an operation, plus, times, divide, and whatever, you take the last two numbers, whether it was a number that you computed before, so on, and whatever, does not matter. That's essentially the idea. Okay, that makes sense. So for token in tokens, if token is equal to, so what are the only possible thing? Valid operators are this, otherwise it's going to be a digit, right? So, or an integer, and it can be an integer in the range -200 to 200. Okay. But it's going to be an item inside the array, right? Okay, so like 13 will be an integer. Okay. So yeah. So either, if token is equal to plus, right? Pass for now, elif token is equal to, so let's look at all the operations. Plus, there's minus. Here we'll do a pass for now. Elif, its token is equal to a multiply sign. I wonder, is there like a switch in Python? Case, I'm not sure. Okay, no worries. Otherwise, we'll do elif token is equal to slash, then pass, else must be an integer between -200 and 200. Here we'll say stack.append int of token, and here for now we'll just do assert int of token is between -200 less than or equal to this, less than or equal to 200, right? Before we append this to our stack, we'll just have that assert and we'll delete that at the very end. And then, otherwise, if it's one of these operations, we're essentially going to do it on the last two elements, right? So here we're going to do num1, num2 is equal to stack.pop as well as stack.pop. Here we'll do stack.append. Okay. If token in, we'll just do, plus, minus, star. Okay, I guess this is fast. I don't want to do a bunch of code repetition, right? Like it's annoying to do, stack.append num1 times num2. It's essentially like I copy this on over to every single case. And then it's just, I do it based on whatever the thing is, right? So this will be a plus sign, this will be a minus. Which one do I subtract by? Let's just be careful. Let's look at an example of subtract. What do I subtract by? Is there no example of subtract? Maybe in the Wikipedia. Where is subtraction? Yeah, okay, so 3 minus 4 is the same thing as 3, 4 minus. So the left num, you subtract by the right number. Okay. So you take the right number and you subtract that, right? So num2 is the right number. So yeah, you subtract by the right. Okay, so that's perfect. Yeah, this is multiply, and then this will be divide, and it says there will be no division by 0, and that you always truncate toward down to 0, right? So assert that num2 doesn't equal 0. And between any two integers always truncates towards 0. Oh, but does Python truncate down? Oh gosh, that's annoying, right? Let me, if I do negative 11 divided by 2, that's not division towards 0. Negative 11 divided by 2, I'd like that to go to 5, right? So, okay, so like, first of all, let's try to run something like this. Oh, also, I'm not returning anything. What do I return at the end, right? Can I just say that there's one thing on my stack? Assert length of stack is equal to 1. Return stack of 0. Can I do something like that? No. Here, you know what, print stack. Okay, wait. Oh, is divide the other way around? Is that what's wrong? Yes, 13 divided by, yeah. Oh, wait. The first number that I pop by is the right number. So, okay, we'll call num1 will be rnum, right? And then num2 will be lnum, right? And so we saw that rnum, yeah, is the one on the right, right? So here we want to do rnum minus lnum becomes lnum minus rnum, right? And then for the plus sign, this is the same thing. For the divide sign, this is the same thing. And for the multiply sign, this is also the same thing. Okay, so let's run that guy. Okay, now this guy is not happy. And yeah, probably because of the negative stuff here, right? So let's do, if I do round of negative 5.5, can I round towards 0? Okay. So yeah, Python is annoying in that it doesn't round to 0. It rounds down no matter what. That's annoying. So if I do negative 11 plus 0 0.5, 10.5 divided by 2. Yeah. It doesn't get me to that. I mean, I could multiply by negative 5. What if I do negative 11 divided by negative 2? Okay. If lnum is less than 0, division is equal to negative lnum over rnum stacked out append negative div. And continue. Okay, I'll do something like this. No. right? Because then I do negative 11 over 2, which is 5. Right. Else interesting plus negative 11 times, what does this become? 10 times 6, so 9 and 3 get added together. Then there's the negative 11. So they get multiplied by that. Yeah, very nice. Okay. Okay, first of all, I'm just going to do if token in, not in, you know, we'll do plus, minus, star, and slash. We'll just do, you know, we'll do plus, minus, star, and slash. Then we do this. Right? And otherwise continue. Okay, okay. Otherwise, we'll do this. Rnum is and Lnum is equal to this. Stack.append if token is equal to a divide sign, now if I do negative 10, okay, if Lnum is less than 0, Lnum plus or equal to 1, okay, and Lnum less than 0, then we'll just do Lnum plus or equal to 1. Handle Python not rounding. Python rounds down instead of towards 0 with division. Location. Okay, now we'll just say stack.append. We'll do Lnum plus Rnum if token is equal to plus, else Lnum minus Rnum if token is equal to negative sign, else Lnum times Rnum if token is equal to a times sign, else Lnum times divide by Rnum if token is equal to a divide sign. And here we'll do stack, yeah, so we stacked and append that result, and there we go. Now does this work? Else, yeah, then this, because it's a divide case. Okay, we still are getting this wrong. Why are we getting this wrong? Okay. We're doing 10, 6, 9, 3. So we're going to print stack each time. So we have 10, 10 and 6, 10, 6 and 9, 10, 6, 9, 3. We evaluate the 9 plus 3, which becomes a 12, sure. 12 and negative 11, yeah, that becomes negative 132, sure. 6 divided by negative 132. Let's just do something like this. L num greater equals 0 and R num less than 0 times or equal to -1, R num times or equal to -1. Make numerator, make denominator positive. Elif okay, let's just keep going. So here's 6 over -132. 6 over 132. 6 divided by 132. 6 divided by -132. It thinks is -1. Oh, because again, it doesn't round towards 0. Okay. If the result is negative, yeah, you know what? This is how we'll do it. This is how we will do it. If token is equal to this, then we'll say new num res is equal to L num divided by R num. If res less than 0, res plus or equal to 1. Stack dot append res and continue. There we go. Okay, so submit. And still wrong answer. Why are we getting a wrong answer? Let's see. It does not quite work that way, does it? Okay, man, this is really annoying, the rounding down. L num less than 0 and R num less than 0. Man, just why is the rounding to 0 just so annoying? Okay, if L num is less than 0 and R num is less than 0. I wonder how I solved this last time. It just seems like an annoying little side effect. Okay, if they're both negative, then just if this or L num if R num is less than 0, the L num times or equal -1, R num times or equal L num equals negative L num, R num equals negative R num. Dude. I wish there was a, okay. I wonder how like the round towards 0 works in Python. I mean, this is just an annoying thing. It's just I'd like to do it in like, you know, a not super inefficient way. Okay, if it's a divide sign, honestly, at this point, I'm ready to just solve it in another language just so we have like, you know, the divided by 0 works in a convenient way. Okay, this is not too much of an issue. It's just a little bit annoying, right? It's just if we divide and it's negative, less than 0, and res doesn't equal L num over R num, res plus There we go. Okay, and now do we need this? Okay. Okay, so can we submit something like this? Output limit exceeded. What am I printing? Okay, I'm printing the stack every time. Okay, let's do this. Let's run it. Okay. Okay, so that's good. Let's submit. And there we go. Okay, bada bing, bada boom. Okay, finally. That was just a little bit tedious for some apparent reason. Let's just do this. Must be an integer. And 200 and 200. There we go. Stack to append int of token. And continue. Otherwise, we take our left and right num. Handle division case separately, since Python rounds down instead of rounding towards 0. Always rounds down. Rounds down. Okay, there we go. Res is equal to this. If res is equal to that. Actually, continue is fine here. And let's just do this. Make it clean. And there we go. Otherwise, straightforward operation. There we go. And now we can delete all this stuff here. We can get rid of this. We can put this assert here. Technically, I can put an assert here. Assert negative 200 less than or equal to int of token less than or equal to 200, but I don't need that anymore. Okay, so let's just run this one more time. Bada bing, bada boom, submit. And there we go. Okay, so now we get 4ms, but it should technically be a little bit faster. Just that I guess, like, it doesn't like this stuff. But that's not a worry in the world. I can also make it more efficient by just doing an if statement. That way it doesn't check those things twice. But yeah, 4ms, we're just right in this range and so on. So like if I submit it a couple times, it might get 0. Yeah, no worries. Okay, so we have 4 milliseconds and so on. But this is essentially the optimal solution. Like if I wanted to make this faster, it's just I have to deal with a little bit of the 011 stuff. But that's not an issue whatsoever. But otherwise, as always, in all my videos, I do a quick recap of how I was able to solve the problems. For this one, essentially, reverse Polish notation is very interesting in the fact that the way that it works is essentially you keep a log of your 2 most recent numbers, and whenever you see an operation, you essentially apply that operation on the 2 most recent numbers, right? So essentially here is like you have the number 2, you have the number 1, then you see a plus sign, therefore, okay, add the 2 and 1 together, right? And then you have the number 3, right? And then it's like, okay, I see the number 3, then I see a multiply sign, then I do the last 2 numbers that I saw, right? So essentially a stack is absolutely perfect for this, right? Because in a case like, let's look at something like this. The way that it works is we want it to become this, right? Essentially what you'll notice is like, okay, there's a bunch of numbers, but what does the plus sign operate on, right? Well, this plus sign goes on the 9 and the 3. You'll notice this is the 2 that came right before it, right? And then this multiply sign, well, it actually happens to have this negative 11, right? So out of all the numbers as you see, it's always the most recent 2 that you apply the operation on, right? So what I did is essentially I kept track of a stack, right, at the very beginning of my program. And essentially I'm just going to append things as they are. So if it's a number, I'm just going to add it to my stack. If it's an operation, I'm going to pop the last 2 numbers of my stack, apply the operation, and put that back in my stack. And I think the best way to understand that is by just, going through an example. So here, for example, I see a number 10, so I will just put the number 10 inside of my stack, right? But I'll add it as an actual integer. So here I do like, int of token instead of just the token itself, right? If it is not, one of the operations, it must be a number. So in that case, if I see a 10, then great. Otherwise, let's look at the next element. Here we see a 6. Okay, let's add 6 to our stack. Here we see a 9. Okay, let's add 9 to our stack. Okay, here we see a 3. Okay, let's add 3 to our stack. And now we see a plus sign, right? And again, remember, we must apply operations to the 2 most recent numbers inside of our memory log, right? So in this case, it's the 2 numbers at the top of the stack. So we pop them, we do I have an L_num and an R_num, and you'll notice that my R_num is to the left of L_num because R_num is going to be the first number I pop, and then L_num the second number I pop. Why? Because the first number I pop is going to be 3 here, right? So, but 3 was to the right of 9, right? So I make this my right num, and then my left num will become this 9, right? So here I pop the 3 and I make that my R_num, and then here I pop the 9 and I make that my L_num over here, right? And so now I essentially have access to these two numbers, right? And then this is the plus operation, right? So I'll just call this, my operation is equal to a plus sign, right? So essentially I need to add this 9 and 3 together, which when I do so is going to give me, 9 plus 3 is equal to 12, right? So here I take 12, I add this result, and I put it to the top of my stack, right? And then I just keep on going. I see the number -11, so I add that number to the top of my stack. Now I see another operation, so let's apply the operation, right? So here our R_num, we'll take this number here and make that our R_num over here. Then we'll take this number here, we'll make that our L_num over here. And then our operation is a multiply sign, so we'll just apply the operation, right? Take the left num here, okay, take the operation, which is this multiply sign, okay, take this R_num, okay. What does this equal? This is 12 times -11. This is what, like -132, -132. It's just 12 times 12 is 144, so yeah, minus 12 is 132, and then negative sign. Okay, so -132, and so then we just add that to the top of our stack, right? And then we keep going. Okay, we see a divide sign, so here's going to be 6 divided by -132, right? But how do we do this? We take this number, we make this our R_num, we take this a 6 here, we make this our left num. The operation we just saw is a divide sign, so we make that our operation, and let's apply, right? Let's take our 6 here, let's divide by -132, and then what this problem says is like, okay, there will not be any division by 0, so you don't have to check for that. And the division between two integers always truncates towards 0. And now, if you're doing this problem not in Python, this will be very simple, right? You just divide and truncate, and there you go, because most languages actually divide towards 0. Python is special in that it divides downwards no matter what. So if you have a negative division, right? So if you do, something like -11 divided by 2, it will do -6 instead of -5, right? Because again, -10 divided by 2 is 5 here, right? If I do -11 divided by 2, it's -5.5. But if I truncate this down, it will go down to -6 instead of to -5. It does not round to 0, it rounds downwards no matter what. And of course, if I do 11 divided by 2, it'll go to 5. No matter what, it rounds down in Python. It does not round to 0 in the negative cases. So I have a little bit of logic here that just checks like, okay, I'm going to try to divide it by truncation. But if I divide the numbers, together, like say like, -11 regular divide by 2, right? And I see like, okay, this is not equal to the actual, like if I did it by truncation. So it's like, if the result, has a remainder and it's negative, then I know that since, Python rounds down instead of rounding to 0, then I'll just add 1 to my result, right? In case it has a remainder and it's negative, then I know I must add 1 just to balance out the fact that Python rounds down instead of rounding to 0. But if you're not doing this in Python, you probably don't have to worry about that edge case, right? But that's just a little thing to consider. So here, I think 6 divided by, well, this will definitely be 0, right? Okay, it'll be -1, but again, if we do 6 divided by -132, we know that this has a remainder and it's a negative, so we'll take our -1 and add 1, we really have 0, right? Because again, we want to round towards 0, not downwards, so we handle that edge case. So this actually just becomes a 0 here, right? So here we just add that to the top of the stack, and very, very nice and good, right? And now let's just keep going. The next operation we see is a multiply sign, so let's change our operation to that, and meaning we're going to take the right number here, okay, that's going to be our new R_num, and we're going to take the left number here, okay, that'll be our new L_num. So let's do 10 times 0. I hope I'm doing things right here, okay, which is of course equal to 0, so we'll add 0 to our stack, right? Now we see the number 17, okay? Let's add number 17 to our stack, okay? Now we see a plus sign, so we're gonna take this operation, we'll make it a plus sign, we'll take the 17 here, we'll make this our right num, we'll take this 0 here, we'll make this our left num, we'll do, the left num here, the operation is a plus, the R_num is a 17, so 0 plus 17, well, that gives us 17, so now we add 17 up to the top of our stack, right? And there we go. Then the next number that we see is a 5. Okay, very nice. We're going to add 5 to the top of the stack. Then we see a plus sign. Okay, let's make our operation a plus sign. Let's make let's pop from the top of the stack. We'll make that our R_num, right? Let's pop from the top of the stack again. Let's make that our L_num. And now let's do the operation, right? So 17 is our L_num. The operation is a plus sign. And our R_num is a 5. 17 plus 5 is 22. So we take that result and we add to our stack. Now here we have reached the end. We have traverse through every single token, the stack should now have one element, which is our result. In this case, we do see the stack has only one element, and our result is going to be whatever's inside, 22, which is exactly the exact answer that we wanted to expect, right? And you'll see, like, if you follow through this alongside as well as doing this little demo over here, you'll realize that it's essentially the exact same step, right? This is just how reverse Polish notation works, which just happens to be very, very, very convenient when you happen to use a stack data structure. So otherwise, that's pretty much it for my explanation. So let's make sure that we check the box saying that we did this problem. And yeah, otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. Otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.